Eyeglasses are available in all shapes and sizes and for a variety of applications. Since we depend so much on our lenses to help us see the world clearly, you may wonder what goes into creating them. At our office, we believe quality care is about attention to detail and satisfying each patient's individual needs, not treating them as a mass consumer. Our office is partnered with an independently owned optical laboratory to produce your lenses. Employing specially trained lens technicians, our partner laboratory utilizes state-of-the-art equipment to create each pair of eyeglass lenses. You can feel confident knowing the eyeglasses you receive have undergone careful inspection at every step of manufacturing to assure you receive the finest quality lenses possible. Prescription lenses can be made with a variety of different materials. All of them require advanced computer technology and skilled craftsmanship to produce. Lens orders arrive to the laboratory by mail, phone, fax, and over the internet. Orders placed over the internet automatically enter the system and are put into production. In some cases, phone and fax orders are received and manually entered into the computer system. After the order is in the laboratory's computer system, the technician begins by selecting a lens blank of the desired material with the proper curves and, if needed, bifocal power. This lens blank will be custom ground to match the prescription prescribed by the doctor. Since the front of the lens blank usually is not ground, a special tape is applied for protection and to keep it from being damaged during processing. A blocker is used to find and lay out the lens, as well as apply the block to the lens. The lens block is placed on the front side of the lens over the protective tape and makes it possible for the lens to be mounted into the lens generator for processing. The center of the block will become the optical center of the lens. This is the point of best vision in the lens. Next, the lens blank, attached to the block, is inserted into the generator and aligned. The generator grinds the required curves into the back side of the lens blank. Controls on the generator enable the technician to set the spherical and cylindrical curves that will be ground into the lens. A cone-shaped grinding wheel with carbide milling cutters is angled so only the outside edge of the diamond cutting surface touches the lens. The carbide milling cutters sweep across the lens, gradually grinding the lens until the desired thickness and curves are achieved. If the lens gets too hot during this process, it can lead to warping or tearing. For this reason, water is used to keep the lenses cool and to wash away the cut material. When the lens is taken off the generator, it is placed in a special surfacing machine to remove any marks left by the generator. To achieve this, fining pads are glued to a block with reversed matching curves, and the lens and block are rubbed together. A surfacing machine can fine two lenses at the same time. Air pressure holds the lens and the sanding block together, and a timer switches the machine off when finished. Similar to the generator, water is used to keep the lenses cool and clean. When fining is complete, the lenses are polished on a similar machine. However, polishing pads and polishing compound are used instead of fining pads and water. The liquid polish flows over the lenses during this process and into a reservoir to be recirculated. When fining and polishing are complete, the lens is optically clear with no visible scratches. The lens block is then removed and the lens is washed and inspected. At this point, special lens enhancements, such as a premium anti-reflective coating, may be applied to the lens to reduce glare and increase scratch resistance. Different lens materials require different anti-reflective lens treatment chemicals. For this reason, the laboratory begins by sorting the lenses into batches of the same lens materials. Once sorted, the lenses are once again washed by hand and manually inspected to assure there are no flaws. Flawless lenses are placed into a special machine that ultrasonically cleans the lenses and then etches them. Much like you would scrape or rough up paint on a house before repainting, the lens etching process assures adhesion of the treatments to follow. A scratch-resistant coating or primer is applied immediately after the etching process and then transferred into an infrared oven to cure. After 4 minutes, a top coat lacquer is applied and then once again transferred into the infrared oven for curing overnight. This process produces a super hard protective coating for optimal scratch resistance. Once the overnight curing process is complete, the lenses are inspected again and then put into the AR chamber lens holding device. During the AR, or anti-reflective application process, air is removed from the chamber and a vacuum is created. A series of chemicals, determined by the type of lens material, are individually ignited with an electronic beam, melted into a gaseous state, and then released into the chamber holding the lenses. The lens holding device continuously spins the lenses and flips to coat the back side of the lenses as well. When the lens has been coated on both sides, the electronic beam moves on to the next chemical in the process, ignites to melt it into a gaseous state, releases into the chamber to coat the lenses, and flips to coat both the front and back side of the lenses. This process repeats multiple times until all chemicals have been ignited and the front and back side of the lenses coated with each chemical. Upon completion of the AR process, the coated lenses must rest a half hour before they can be handled. When ready, the lenses are inspected again and then repackaged back into their trays for finish room processing. At this point, the lens is almost done. However, it still needs to be sized and shaped to fit into the eyeglass frame selected. The lens blank is shaped using an edger. The lens must again be prepared to accept a chuck, but since only the edge is being cut, a much gentler system is used. A small chuck receiver is placed where the geometrical center of the finished lens will be and oriented on the 180-degree axis. An adhesive pad helps to hold the receiver on the lens. The lens is mounted into the edger and held in place by a pressure pad. The computer that controls the edging process downloads the frame pattern information to be used. While the lens slowly turns, a fast-turning cutting surface grinds the lens to the exact shape and size specifications. The lenses, now cut to the correct size, are ready for final inspection and insertion into the frame. During final inspection, a technician checks the finished lenses for scratches and imperfections. They also double-check the fit and orientation of the lenses in the frame. Finally, the finished eyeglasses are thoroughly cleaned and packaged for delivery to the patient at the eye care professional's office. This system of multiple inspections and the blend of skilled craftsmanship and computer-controlled lens manufacturing make it possible to get the finest quality eyewear without waiting weeks. We promise to provide patients with the best quality of lenses they expect and deserve for their eyes.